Welcome, everyone. My name is Mikhail Stefuka, Program Manager for Automation and Customization. Together with Stefan, we'll go over this agenda today with you. We'll start with general updates, go over Python APIs, what's new there, give you an update on extensions, move over to improvements on HWC, command recording language, and we'll close the webinar with the process automation. But first, general updates. First topic, in version 2024, we are saying goodbye to the utility menu. It is probably something you will hear about in other webinars because it is related to other topics other than just automation and customization. You might have seen that the content of the utility tab has been decreasing over the last few releases until we reached the point that in 2024 version we could completely remove it. The core solutions that have been exposed through the utility tab have been migrated to other places, integrated in ribbons or other workflows. And the reason why we're talking about it here today, of course, is that it was also an entry point for custom content. Now, why we're moving away from it is that we want to unify entry points for custom content and guide users through extensions. So for any existing custom scripts, features that you want to expose to user, extensions is the platform to follow. This means that macro files will no longer be supported. And you might find yourself in a situation where, of course, you used it to expose scripts, solutions that fit your workflows, and you want to keep working with them. We've got a solution for you. So the installation will contain a script that will help you here. But I will let Stefan cover the details in his extensions section of this. The next update is on Matrix Browser. For those of you who have used it, also in the past in the classic interface, you'll be pleased to know that we brought back the HyperView workflow. This means that you can work actively with Matrix Browser also inside your HyperView window. That brings back the entity selection, results integration, and also the other extra tools that are available there, such as HyperView notes, creating screenshots if you have both HyperMesh and HyperView window in one session. That's all working. It's all back there. This is probably, honestly, the kind of last big, hooray for Matrix Browser. Going forward, we'll be focusing on bringing these functionalities in the core browsers, as you know them, model browser or table of content as we refer to them as well. Right. So keep an eye on those, and we'll try to bring the same experience there. With the general updates out of the way, let's move on to the big boulder of today's webinar, and that is Python API. So the stories we would like to share with you today is going maybe bit back to 2023.1, where we introduced HyperView and HyperGraph Python API. So this was a kind of big step for us in terms of bringing this new experience to the user in terms of scripting. We introduced the basic workflows there, and also the standard framework classes such as pages, windows, and things like that. Now we're happy to announce that 2024 will also introduce HyperMesh Python API, together with more HyperView and HyperGraph classes. So again, big shout out to the development team and to the QA team, because this was a project that, as you will see, hopefully, and get the impression on the following slides, the scope of this project was huge, and a lot of effort went into bringing Python API in HyperMesh client to you. Few key points I would like to make with respect to Python API. First of all, with 2024 release, we are now supporting the three major FE clients in our application, which is HyperMesh, HyperView, and HyperGraph. This brings really a kind of consistent and good experience to the user. Also, I want to mention the MotionView client supports Python API as well. Key information here is that we are adding Python API. Python API and TCL API will be exposed side by side. Users can still use their TCL scripts. Nothing has been changing there. We are not replacing DCL API with Python API. We are simply adding it at this stage. That being said, the momentum will be shifting towards Python. More effort, more activities will be targeted towards Python, and we will be slowing down the activities on DCL side and following, similar approach that we did with the UI. So the investments, and we're counting with Python going forward. Point number 3, the Python world or environment brings also the huge benefit of all the existing solutions that can be leveraged. The Python installation in HyperMesh or packaged with HyperWorks applications in general includes more than 600 different libraries and modules, including the number 1 hits, pandas, numpy, scipy, AI packages, plotting packages. And this also includes our own libraries, of course, including the GUI toolkit that allows you to build custom dialogues, custom GUIs within our application that have the same look and feel as the rest of the user interface. Although IPython console was technically introduced already in version 2023, and of course with the Python API coming in .1, it's something that you as users are familiar with already. But I want to make the statement here, we're using the IPython console, which is an interactive one, has a lot of goodies that you can leverage in everyday use, and it exposes Python 3.8.10. Last but not least, documentation. Documentation will cover all 3 clients, HyperMesh, HyperView, HyperGraph, and also a few new things that we are introducing in 2024. As a quick sneak preview, let me jump into a development build of the help. Once you go into API reference guides, you will see the link to Python API. Please excuse the description. It hasn't been updated yet, but in the final version, you'll see it accurately describing the content. So once you're there, you will notice, comparing to 2023.1, that we have added new chapters, namely HyperMesh, Task Manager, which we'll discuss shortly. And also we linked to the GUI toolkit, which is something that our applications in general, so as I will, I think, explain in a few slides, share same set of APIs to create GUI customization. Diving very briefly into the HyperMesh section, you will find the user guide explaining usage of different classes, selections, links to the function documentation, where you will find the details about inputs, explanation of the new features that are very Python specific, and as every chapter in this guide gives you a set of practical examples. So we're really hoping that this will help onboard users with our Python API. But of course, we do not consider this to be a final product. We really welcome your feedback on the information provided here, and we'll be happy to work on this in coming into the next releases and bring more information through there to you. The introduction of Python API in HyperMesh, HyperView, and HyperGraph is another step in our mission of convergence, as we call it. A few years back, we jumped on or embarked on the journey of unifying the user interfaces. If you open our applications today within the HyperWorks suite, such as Altair HyperMesh, Inspire, SimLab, Compose, all these applications have the same look and feel. Whichever you open, you don't look surprised, or it's not completely new environment that jumps at you. And it has a huge benefit in terms of shortening the learning curve and making sure that the moving between applications is as easy as possible for the user. If you think about this as the front end, we can consider the scripting language as the back end. Again, we are trying to follow the same mission here, really. We're trying to unify the user experience there. So we're moving to common scripting language, which is Python. We're trying to share more and more components, and a shared component, again, means a shared API. And all this is helping us to break the barriers between the applications and allow user to move more freely between them, including the data. And I'll conclude the general overview of the Python API intro with a little recording which some of you might be familiar with already. But what I want to highlight here is that we understand that Python API is a standard. It's an industry standard, right? We don't want to pretend that we are kind of reinventing the wheel and that our wheel is rounder than others. But we want to highlight here that we're really focusing on the integration of the Python ecosystem with our applications. This is going a bit fast, so let me just rewind a bit and pause at various points. What we're highlighting here is really leveraging of some of those 600 libraries that are part of the installation. So you can integrate Plotly in a web window in the application. You can integrate, if I manage to play it again, you can integrate the matplotlib package and use charts directly in the console. You can integrate, websites essentially, viewing website in the main HyperMesh window and take advantage of that. And I think the last demo here shows how we can use Plotly directly in the chart manager, which Sandesh and the team introduced the updates in the last week's webinar. So really, this is where we feel the huge benefit for the user comes from all that the Python world brings to them. The details of HyperMesh Python API. Now, when I say details, we'll not go too deep into this. We will be covering the syntax and all the technicalities in next week's webinar. So we're keeping things relatively high level for today. As said, without going into too much scripting and let's say, coding, I wanted to provide an overview of the project and really give the audience a feeling what we focused on when we're saying we brought HyperMesh Python API to you. So if you think about HyperMesh as the application, and as a user looks at it in terms of what they need to script, there are a few aspects of it, right? It's the database, it's the actual data that the HyperMesh model holds. You need to be able to create entities, of course. Inside, you need to be able to interact with them. You need to be able to access the services that the application gives you. So it's the meshing, the geometry editing, really what makes HyperMesh special. Those services typically require an input set of entities, right? So we need to be able to select them or collect them in some way. In order to work efficiently, you might want to customize the environment and control certain preferences. And last but not least, you might want to optimize the GUI or bring your custom GUI in a natural way into the application. So all these things had to be considered during this project. They, of course, interact with each other. So we didn't want to look at them in an isolated way. Now, the benchmark really was the TCL API, right? Whatever we exposed and brought to the user, we wanted to make sure that the same capabilities can be accessed through Python API. This means, more than hundreds of commands on the GUI side of things. User has more than 140 options how to select entities. Looking at the data names and entity types in the database, we're approaching 200 different types, and of course services. That's a huge package there. We've got 2,000 modified commands and 600 query commands, let alone the hundreds of options that the user can control. So all these things had to be considered when we're building the Python API. The focus of the project was on these three components: the collection, the database, and services. We believe that this is where most of the scripting takes place, and this is what we focused on. The first two on the left-hand side, they really leverage a completely new infrastructure. They are very object-oriented. They do not share anything with the old infrastructure, and they truly bring object-oriented experience to the user. With the services, if you think about it, we really had a set of functions that have been exposed through TCL, and we try to leverage the same on the Python side. So we try to expose the same code through Python, which means the feeling is a bit more procedural comparing to collections and database. On the plus side, especially users familiar with current scripting interface, will find it very, very. We're hoping they will find the transition very comfortable. All these functions, as we refer to them, are exposed as model class instance methods. which also means that the Python API is very multimodal friendly. Going back to the coverage, almost 100% in both categories have been covered. So we're planning to reach 100% in the next release, with few exceptions where we are thinking about going a bit deeper in terms of restructuring the code and exposing things in a different way. But I'm hoping that this gives you a strong confidence that what you've been doing through TCL API in the past, you will be able to achieve in Python API. And I will conclude with a very, very small, short video. As I said, we'll go into more scripting in the next week's webinar, but just to give everyone a preview how scripting in HyperMesh using Python API will look like. So we'll start with importing two modules, HyperGen module and HyperGen entities module. They include everything we need. We'll need to start by creating a model object there. As I said, multi-model environment allows us to. So we create a model object that gives us access to the model. And from there, we can start performing the operation. So here, as a quick example, I've created a collection of elements. As you can see, the pop-ups will give you information about each class, its functions, etc. Here we created a collection of elements. Nothing was specified in terms of how I want to select them or collect them. Hence, it's collecting all of them. And then we're using HyperGen get mass. I'm using a question mark at the end in case you don't remember the inputs. You can verify directly in the console. Then we pass the collection as the argument, and grabbing the result object, which is returned together with the status object, we can look at the total mass, total volume. Again, user has the feedback based on the names about what information they're looking at. Okay, and if PowerPoint was working with me here, we could see at the end that we are just running a identity command to showcase the usage of a modify command, right? And with this, I will hand it over to Stefan to go over the updates on the HyperView, HyperGraph side, extensions, and HWC. Stefan, over to you.
Okay, my name is Stefan Eberhardt, and I show you the news in 2024 for HyperView, HyperGraph from the post side, and then extensions and HWC, what's new. So for HyperView, we added two more classes. Here in red, you see what's already inside, the selection and the node class, big classes. From the demo side, I will show for Python only two small demos. The big one and with all the coding, as Mikhail already mentioned, we will show next week. So the nodes are covered with the node class. You see here, we support all the properties here. Some of them are used to create this node, formatting it. And we also added some help. So if you create a node, you can from the object get all the valid expressions, which you can use in the text for the current state of the node. I quickly show here a demo. So run here, you can go switch here to Python and run the demo. So the code, the node is created with a Python script, and here you see I showed here the full dictionary with all the expression which you currently can use. It's attached, so control legend, etc. So let's go to the next section cuts. We added the classes section cut planar and spherical. Of course, all the positioning and orientation methods are supported. So you can do it exactly like in the GUI with the node IDs, with the coordinates, etc. And important is we also have intelligent default settings here, which we'll see next week. So that when you just create the section cut without any input, it will behave pretty much similar what you are used from the section cut context. So for HyperGraph, you see here the new classes. We have here 6 new classes. The big one is the curve complex, which contains all the vector classes inside. So then we have a data file, which allows you to look into a plot file to get the header information, the channel information. Then the data file query, if you want to get the values out of it. and the create curves by file and multiple files allow you to plot highly efficient, similar to the create curves by file panel. Let's start with the complex curves. So the class is curve complex. You see on the right side, I create a bunch of curves. Here I use real and imaginary vectors. And at the end, I just shade between the last and the second last created curve, the area between the curves. So yeah. If you want to delete and do other higher level stuff, it's on the window class. For the plot, if you want to get the channel info, I can create a data file object. For this one, I can get the types, and for the types, the request and components, and I also can have the meta information. So how does it look like when I run the code and show it in the IPython console? You see here on the left side, I show the data types, and for the second data type, the requesting components and metadata. And here you can see on the right side how it will look in the create curves by file panel. As I said, you can also query the metadata easily here. For the plot file query, I have the data file query. So here in this code, I create the data file, get the channel information, the headers, and this one I provide to the data file query object. Here I use wildcards, which we also support, and include also the time vector here. And then I can ask the values in one shot as a NumPy array. You see first one, the independent vector, and then all the others. Or I can query in pandas format and then use pandas to immediately plot as I used to be, as pandas provides. So let's have here a quick, okay, let's run the script. That is NumPy and pandas. So as you see here, in the background, I create the link to the plot file, and this here pushes the NumPy array out, and then from this file, the pandas frame is plotted. Now let's come to the plotting. Plotting will be done by the create curves by file object. Here you see I create it and provide the file and then the type requesting component which I want to plot and an additional layout options if needed. Here you see the output if I run this script. And this one is exactly what when I would use create curves by file with some formatting option from the GUI. So very high efficient. It automatically defines the independent vectors, x, etc. It does it all with intelligent defaults. Very high efficient to really plot a lot. For multiple files, we do the same, but we also add the multiple files class. The multiple files class create file set. Mandatory for this class is only the directory, the list with a relative file path and formatting option if needed. So here, this multiple files object here, you see it's exactly the same when you would create the file set with create curves by file with the source file. And then when I plot it, I use again the create curves by file object and provide instead of a file, the file set, and use the formatting option as known, and it will automatically plot. So very high efficient tool. So that concludes the Python part. Let's start with extensions. With extensions, we have also some nice new features. Customer asks for auto load, so that, for example, when I have the HWX plugins environment variable and load automatically a bunch of extensions, that they are auto loaded, and that we also can block the unload by making the slider, disabling the slider. So this is here the two keywords in the central extension.xml file. With the settings, you will see the slider, it's automatically loaded and it's disabled. For advanced customization users, we also enhanced the custom documentation support. It's now with the help section, you can provide a documentation package inside the extensions, which you can start with the F1 key if the scripted context is active. Mikhail already said that an important new feature for 2024 is the new Mac2 extension utility. This converts HyperMesh macro Mac files to an extension. It's located in your Altair Home desktop utility and the directory Mac2 extension. It contains the executable, the script, plus and README how to use it. The command syntax is you run Python with the script, and then if you have a lot of templates in it, for example, using environment variables or customization or parameterization of the code, you have to give the path to the template.exe and then the Mac file, of course, and other options, and last not least, the extension directory, where this will be saved in. So here you see inside of, when you run this, inside of the directory, the init file, extensions, ribbon, XML, etc. will be created, and it will create a functional drop-down menu with a flat hierarchy. Here I use the name from Mac, and then you get one page and all the actions, all the commands are now converted to actions. The action tags are unique, and you already have the commands in it, and the tooltips, etc. are working. But be aware, it's not a polished extension, it's a flat list, but it helps a lot to convert your Mac files to extensions because very tedious work is taken away from you. Now let's come to my last topic, HWC language. We added copy and paste here, and this is the first time we also record in HWC from the session browser. So you see here, I have here on the right side, I loaded a model and split the page, copied it in all windows for Windows, then copied the whole page, pasted it again and overlaid it. And this is what you got slightly modified on the right side if you have TCL logging on. And this is when you do it interactively. Here you have the window, you copy and paste, overlay it, etc. And also for the page, you can see you can do it, copy the page, paste, overlay it, etc. And you can also do it if you want to see the options, of course, like HWC in the command line, type it and see the pop-ups. One thing I want to mention is multiple pages can be copied and stacked via append. So if you type in your console page copy and then page ID 1 and with append true, then you can append 1, 5, 6, 7, whatever, and then paste the stack or overlay the stack on a given location on a page at a given location very easily. So that makes customization very convenient here. I just want to run here the demo. So this is when we do the TCL log. And you will see here the TCL script runs, which was logged and recorded, and everything is done. I clear the console, and now let's go to the really interesting part. We now have added copy and log to Python for HWC. So here you see exactly the same action on the left side, which I've done, and on the right side, this is the log if I have activated log to Python. And here you see that first it imports the utilities so that the eval HWC command is active. So if you do this and rerun the command, make sure this line is included. You can activate it in the console via the right mouse button, load to Python, or if you want to copy in Python syntax, you can do it here right now from the history of the command. And then the handling of the Python log file is exactly the same. Like you know it from TCL. So by default in the working directory, you can change, and you can also change the mode if you want to overlay, replace it, etc. And just please make sure that when you rerun the commands that you import the utilities so that you're sure your wrapper is working. That demo, so quickly, you see here the HWC, and I run this exactly the same, the Python script, and you see the Python commands pipe out, and the same commands will be logged again. I haven't blocked the logging here for demo purpose. Okay, that concludes my part of the presentation, and I hand over back to Mikhail.
The last topic we prepared for you today is process automation. We've got a few updates there that we would like to share with you. Starting with the first information, the legacy process manager has been completely removed in version 2024. That means the code is gone, the related APIs are gone, so any existing solutions will no more be runnable in version 2024. The solutions ideally will have to be transferred to the task manager that we introduced in 2024, together with actually a new ribbon. So let me spare a few words about that. The ribbon is hidden by default. You will be able to enable it through View, Ribbons, and check, add a little checkbox next to it. At the moment, it hosts only the access point to the tasks or the task manager. But as I mentioned earlier, we've got a few things in the pipeline for you. And this is the place where we would like to then expose them. So keep an eye on this space in the future releases. Now back to the topic of Task Manager. It is a new, very lightweight solution to organize your scripts, your tasks into a concise process that can be presented then to the user. At the moment, it supports a HyperMesh client. In the future, we are going to extend the official support for other clients as well. Most importantly, it works only with Python API. Process structure, as well as the task dialogues, are fully defined in XML files, and they're linked to your Python code that defines the business logic. That means that they're very easily portable to future solutions, as I will explain in a few seconds. The format of the XML file, the keywords, as well as the Task Manager Python API, they're all included in the documentation. If you might have noticed when I was showing you the Python user guide, there is a dedicated chapter for Task Manager there as well. So all of it you will find in the 2024 documentation. Just very quickly, let me show you how it works and how it looks in action. So developer ribbon, we call the Task Manager. We open the XML file defining the process and load it in. Immediately, we've got the structure there. And as you click on the first task, you've got the GUI defined, right? So the process, the individual sections of the process, as well as the GUI itself here, is fully defined in XML. The second I execute the task, it goes into the Python API business logic. So it's leveraging the Python APIs that we've been talking about earlier in today's webinar. Task Manager fit into the long-term plan. Let me jump into the next slide. So going back to the topic of Process Manager, Process Manager kind of closed its full production mode few versions back, and it has been in the maintenance mode until the 2024 release. At this point, as we removed the code, we introduced the Task Manager. And the Task Manager really covers, obviously, the needs within the application, right? And specifically HyperMesh client at this point. Now, going forward, we are thinking a bit bigger, and really we are seeing process automation as something that you really want to build across multiple applications. So in parallel to this initiative, Altair has been working on the Pulse application that is our process orchestrator. At the moment, Pulse is focused on orchestrating processes across applications exclusively, but in the future, we're planning to introduce the capability of looking inside the application, if you will. So Pulse will be able to orchestrate processes within a single application. And at that point, users can move between Task Manager and Pulse as they need to. The idea is, and the main reason why we kept the Task Manager infrastructure very, very lightweight and defined through XML, obviously it's the ease of use, but also it's the compatibility with future solutions. Pulse today also uses similar approach with GUIs being defined descriptively through XML or JSON files. So we will provide mechanisms to easily move from Task Manager to Pulse in the future. Okay, so keep an eye on it. Pulse is our solution for process automation, and it will grow nicely inside the applications as well. Again, goes back to the topic of breaking barriers between applications and really leveraging the best of every possible service that the HyperWorks applications. And with this, I'll conclude the webinar. A big thank you for joining us, and hope you enjoyed.